I want to break down the Monty Hall problem. It's a very, very popular problem, especially in the world of probability. I want to break down the Monty Hall problem and why does it work the way that it works. So let me first just explain what it is. Monty Hall was a TV host of a very famous TV show, I believe it's still on today, called Let's Make a Deal. So the problem is commonly referred to as the Monty Hall problem because he was the host. Here's the premise of it is there is 3 doors, door 1, door 2, door 3. There is a pretty nice prize behind one of the doors, and behind 2 of the other doors is a goat or some other bad prize. So for my setup, I'm doing, you could win a car behind one of these doors, behind the other 2, you're gonna get a goat. Now, it's just me here, so what I'm gonna do is I'm gonna use a die to kind of help me set up this problem and do it. To choose what door we're in, so that way if you're like, well, you know what's behind each door, I'm gonna use the die to select the door. So if I had someone here to select it, I would do it, but it is what it is. So I have door 1, door 2, door 3. So the first thing they do is they bring a contestant up and they say, well, which door would you like to pick? So if I roll a 1 or a 2, I'm gonna pick door 1. If I roll a 3 or 4, I'm gonna pick door 2. If I roll a 5 or a 6, I'm gonna select door number 3. So a quick roll here says, hey, I rolled a 5. So I'm really happy with door number 3 right now. Okay, so that's how the problem starts is the contestant comes up, he picks a door, and they're like, hey, I like door number 3. Now what Monty Hall does is he says, hey, we'll get to door number 3 in just a second, but before we show you what's behind door number 3, let's show you what's behind one of the doors you didn't pick. Okay, so what he's going to do, and he does it every single time, is he's going to show you one of the other doors. So what I'm going to do is I'm going to show you, hey, if you would have selected door number 1, you would have got yourself a goat. And, the audience goes crazy. Oh, my God, a goat, whatever. So the contestant's still standing there, and Monty asks them, and this is the key question of it all. Now that you know this, would you like to stick with the door you selected in door number 3? Or would you like to switch to door number 2? So he gives them that dilemma. Stick with what you originally picked or flip on to door number 2, and it's up to you. There's a wide range of people on how they answer this. Some people go the emotional appeal and are like, I'm going to go with my gut. I'm going to stay with door number 3. Other people are just like, oh, I don't want to second guess my, whatever. The incorrect valuation is people look at this and they say, well, it's just 2 doors, right? And one door has a goat and one door has a car. So that's 1 out of the 2 doors has a car, so it's a 50-50 shot. It doesn't really matter, okay? So whatever the contestant wants to do, they let them do it. So maybe, this time I'll say, hey, the contestant's going to say, I'm going to go with my gut. I trust my gut. I'm going to stick with door number 3. So they say, all right, let's see what's behind door number 3. You won a goat. Womp womp. Okay, and if they would have went on and switched to door number 2, they would have won a car. So that's kind of the premise of the problem. And we're going to break down the probability here in a second. Again, I'm going to just shuffle these around. And we'll play it again. And we're going to talk about, what is the common answer of what people say and why is it incorrect. And then we're going to answer, and I'm going to tell you why the answer is what it is. So let me take a look, make sure we're all shuffled here. Okay, so right now I know where the car is because I'm the host of the game show. I kind of have to know. Pull another contestant. Again, I'm going to roll. That's off the screen there, but I rolled a 6. Okay, I rolled a 6. So again, I'm going to go with door number 3. Door number 3. So Monty Hall says, great. We'll check behind what's done door number 3 here in a second. But before we get there, what I want to know is, let's show you what's behind one of these other doors. So this time you might go, let's show you behind door number 2 is a goat. The crowd goes, laughs, whatever. Okay. So then he presents them. The big question that everyone wants to answer is, would you like to stick with door number 3, your original door, or would you like to switch to door number 1? Okay. So the incorrect assessment here is people say, take this out of the game. You got 2 doors again. One has a prize, one does not. So you win 1 out of 2 times. It's a 50-50 shot. it doesn't actually matter which door you pick because it's 50-50. You have an equal chance on both. That is incorrect. There is a strategy on how you do this, okay? So maybe this time I'll show you. They say, oh, I'm gonna switch. I want to switch money to door number 1. They show you behind door number 1. Ah, dang it, we got the goat, okay? So let's break down and talk about what the real percentage is here, okay? What the real percentage is here. And I'm going to mix up one more time, and then I'm going to pull some probability out and show you why things are the way they are. So let me make sure I know where my car is. Whoops. So I have my new setup. I'm going to roll, and I rolled a 3. So right now, I've selected door number 2. Okay, so let's talk about some basic probabilities here. Basic probabilities. I've currently selected door number 2. Okay, there is one car and there is 2 goats. Okay, there is one car, there is 2 goats. Car is winning, goats is losing. So let's just think about it. What is the probability that it's at our door? Okay, what is the probability that it's at our door? Well, there is only one winning option out of 3 total options. So you got a 1 in 3 chance, which is 33.3333, repeating, 33% chance that it's at our door, okay? Notice I'm not saying door 1, door 2, door 3, just what's the probability it is at our door. Let's figure out this other probability. What's the probability that it's at a different door, okay? I don't care specifically where it's at. What's the probability that it's at a different door? Okay, so if we look at it, well, probability that it's at a different door, if there's a 1 in 3 chance that it's our door, the chance that it's at a different door is you got 2 out of 3 chances that it's at a different door. And why does this work is, well, these should add up to 1. So the probability that it's here is 1 out of 3. The probability that it's somewhere else, a different door, is 2 out of 3. The reason we know this is those need to add up to 1. So as there is a 66% chance it's somewhere else. Notice again, I'm not saying specific doors. Probability that it's at our door is 33%. Probability that it's a different door is 66% chance. Okay, so back to the problem. I kind of forgot where my items are. You know, Monty says, hey, that's great. You selected door number 2, but I'm going to show you what's behind door number 1. And they says, oh my goodness, it's a goat. Good thing you didn't select door number 1. So then the question comes in. Monty says, would you like to stick with door number 2 or would you like to go to door number 3? Okay. Would you like to stick with door number 2 or would you like to go to door number 3? Now what people do is they get caught up in the numbers there. Door number 2 versus door number 3. No. Would you like to keep your door or go to another door? Would you like to stay at our door or go to a different door? Is really what he's asking. So it's not so much door number 2, door number 3. It's, do you want to stick with our door or go to a different door? And some people are like, well, wait a second, there's a goat there. Doesn't that change things? No, it doesn't. There's still one car. There's 2 goats, okay? There's still 2 goats. I did not eliminate a goat. There's still 1 car and 2 goats. So these probabilities are still the same. So there's a 33% chance he's at our door is what we just calculated. The probability that he's at a different door is there's a 2 in 3 chance. So really is what he's asking, do you want to go with a 33% chance that the car is here, or do you want to go with a 66% chance that the car is at a different door? Well, Monty, I would like to use my odds in my favor and say, let's go with the 66% chance. So I'm going to switch, and let's check behind door number 3. Oh my goodness, I want a brand new car. It's beautiful, okay? So the Monty Hall problem. Stop worrying about doors 1, doors 2, doors 3. More think of it as our door and a different door. Our door, your original door, is always going to be a 1 in 3 shot. You got it right. Always. There's a 1 in 3 shot you won, which means there's a 2 in 3 shot it's somewhere else. Okay? So when he's opening a door for you, when he's showing you one of the doors, he's not changing the probability. He's just reducing the different options for a different door, okay? So we had our door as door 2, if it does help you to see the doors, and door 1 and 3 were the other ones. So there's a 1 and 3 shot, it's behind door number 2. There's a 2 and 3 shot, it's behind these doors. What Monty did for us is he says, let's take away that door. These don't change. It's still a 1 and 3 shot, it's behind door number 2. 2 and 3 shot, that's behind door number 3. So this is the Monty Hall problem. The gist of it is, it's a 33% chance versus 66% chance. It is in your advantage to always switch doors. There's a 66% chance it's elsewhere, only a 33% chance it's at the door you selected. So I'm going to sort again, show you one more time. I need to know where they're at. Okay, so you pick a door. I picked door number 6, or sorry, I rolled a 6, which means I picked door number 3. So Monty Hall says that's great. Oh, there's a goat behind door number 1. If we follow our percentages here, there's a 66% chance it's at a different door, 33% chance it's at our original. So there's a 66% chance it's here, there's a 33% chance there. I'm going to use probability to my advantage, say I would like to switch Monty, and voila, there you go. There's the car. So if you switch doors, you should win 66% of the time. But it is possible still to lose, okay? But it's not as often. So that is the Monty Hall problem. It can be rather difficult to kind of explain and understand exactly what's going on, but hopefully I illustrated that for you.